Today we're looking at 4 marks of this radian question. Part B is about numerical methods. Nobody really wants to do that, so we'll just stick with pi. So we're told that the chord AB subtends an angle of theta radians at the centre of a circle, as is shown in the diagram. This angle theta subtends the arc AB and the chord AB here. The chord divides the circle into 2 segments, which is segment 1 up here and segment 2, the big one, down here. And those areas have a ratio 1 to 2, and somehow we need to show that sine theta is equal to this lovely expression. So let's work out some areas. I'll start with the area of the smaller sector here. The formulas that we need to know for a sector are 1/2 r squared theta when theta is measured in radians, which luckily in this question it is. So 1/2 r squared theta. We don't know what r is, so I'm going to leave it as r. We also don't know what theta is, so I'm going to leave it as theta. How helpful is that? The minor segment is the smaller segment, which is up here. That can be found by thinking about the sector and then taking away the triangle. So we know the sector is 1/2 r squared theta. I've already written it twice up here. The triangle I'm going to subtract. We can use 1/2 AB sine C. A and B will be r and r, and sine of C will be sine of theta, because theta is the angle between the two sides. The area of the larger sector, the formula is still 1/2 r squared theta, but the larger sector does not have an angle of theta. What's this angle of the larger sector? You might say 360 minus theta, but we're measuring it in radians here, so it's actually 2 pi minus theta rather than 360 minus theta. The r squared is still r squared because the radius hasn't changed. So the area of the major segment then, that's this bit here, basically everything that's not the minor segment, that will be the area of the major sector and then add on the triangle. So that's going to be what we just got, that's the large sector, and then we're going to add on 1/2 AB sine C, which is exactly the same as what we subtracted up here. Now to put it together, the segments are in a ratio 1 to 2. So the minor segment has the 1 and the major segment has the 2, which means we need to times the minor one by 2 and it should equal the major one. So 2 lots of all this will be equal to the size of the major segment, which is this. And now we get to expand and simplify. So this 2 wasn't on the screen before, but there should be a 2 there. Times out the 2 in the brackets, we're going to get this. I'm now going to times everything by 2. Probably could have done this ages ago, but I'm now going to divide by r squared here, 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 and here. I'm now going to add 2 sine theta onto this side. I'm going to add theta onto this side, and I'm going to minus 2 pi onto this side. The reason is the question has sine theta equals, so it feels good to get sine theta on its own. The sine theta will be 1/3 lot of 3 theta minus 2 pi. Therefore, sine theta is equal to theta minus 2 pi over 3, which is exactly what they wanted us to show. Well, there you have it. That's today's question complete. How did you find it? Here are 2 extra questions to have a go at if you want. Catch you in the next one.